That's 304.
Yep, looking good.
The disintegration of the Space Shuttle Columbia in 2003 was a blow to the nation.
GC flight. GC flight. Flight GC, lock the doors. Copy.
For NASA, it was unthinkable.
We were at the landing site, and then all the cell phones started going off with the astronauts that escort us, the family escorts. And then, boom, all of a sudden we're rushed to vehicles.
Columbia was America's first space shuttle, and it redefined what a spacecraft could do. It took off like a rocket and landed like an airplane. It was reusable.
NASA really believed that spaceflight was going to become routine, and they really believed that it was their responsibility to build a vehicle that would make spaceflight something that happened all the time with relative ease, comfort, and inexpensiveness.
But the loss of Columbia forced NASA to reevaluate the very idea of a space shuttle. Just as the loss of Challenger 17 years earlier killed the dream of safe and routine space travel.
Challenger, go with throttle up.
They all kind of had conflicting design requirements as a result of trying to get too many people agreeing on a single vehicle. The accident, in effect, was planned from the moment of the conception.
It's a tragedy that it took the loss of 7 lives to force the realization that there had not been a compelling, strong rationale for sending humans into space.
The tragedy highlights deep questions now facing NASA as it designs the next generation of spacecraft and determines the future of America's role in space. Up next on NOVA, Space Shuttle Disaster.
Major funding for NOVA is provided by the following. The David H. Koch Fund for Science, supporting NOVA and promoting public understanding of science. And by the Corporation for Public Broadcasting. And by contributions to your PBS station from viewers like you. Thank you. Additional funding from Lockheed Martin, inspiring tomorrow's engineers and technologists.
Launch is its acceptance of the risk.
20 seconds and counting. T-minus 15, 14, 13.
The first time's okay because you don't know what they're going to do to you. It's the subsequent times are hard.
T-minus 10, 9, 8, 7, 6, 5.
The vibrations and the noise are such that you cannot believe the shuttle and its systems are going to tolerate this abuse.
On January 16, 2003, mission STS-107 took off from Cape Canaveral aboard the Space Shuttle Columbia.
Roger, roll, Columbia.
It is shaking so bad, you're afraid you're going to lose your teeth. I mean, it's hard.
Columbia, you set your go at throttle up.
Go with throttle up.
The commander of the crew was Rick Husband, veteran of one previous space mission. His pilot, Willie McCool, was flying for the first time, as were mission specialist Dave Brown and Ilan Ramon, the first Israeli in space. Payload commander Michael Anderson, flight engineer Kalpana Chawla, and Navy officer Dr. Laurel Clark completed the crew.
I had been concerned about the erosion of safety culture, and that's based on my observations in the involvement I had taking care of the crew. And I can remember discussion I had with my wife before the mission. When I talked to her about how risky spaceflight was, and I went through some examples, her response was very interesting. She goes, well, if it was so risky, why didn't NASA tell me that? At the time, she thought I was just being negative.
Since the Shuttle Challenger accident in 1986, 17 years earlier, NASA had clocked 87 successful missions. But the spacecraft the crew was flying that morning was still considered experimental. The Shuttle is the most complex spacecraft ever designed. And liftoff is especially unforgiving. Once the rockets fire, there's no turning back.
The particular phase of the mission that's always been the most challenging is the launch. You've got a lot of energy there that's being unleashed. The ability to do anything during that first 2 minutes with the solid rocket boosters is non-existent.
Tracking cameras followed every second of the launch. But until the images were analyzed the next day, no one would notice anything wrong. It seemed a perfect launch. Eight minutes later, Columbia was in orbit, and the crew began a mission dedicated totally to science. Columbia was the oldest shuttle in the fleet, and the only one not designed to dock with the International Space Station. Ironically, this shuttle was originally designed with a space station in mind, but not the one we have today. The original plan was far more ambitious. In fact, the story of the shuttle really begins during NASA's glory days of Apollo, as Neil Armstrong was preparing to land on the moon.
Houston, Tranquility Base here. The Eagle has landed.
NASA did a lot of planning in the late 60s and early 70s of what its initiative after Apollo should be.
That's one small step for man.
That got grandiose after the success of Apollo.
One giant leap for mankind.
12-person space station by 1975, a 50-person space station by 1980, and a 100-person space station a few years later. And they realized that throwing the rockets away every time would kill the economics. And so you needed something reusable. You needed something to shuttle from the Earth to the space station.
But as NASA was planning the future, the powers in Washington were planning to slash NASA's budget, starting with the remaining Apollo missions.
Nixon took us out of lunar exploration. That administration canceled the last 3 Apollo missions for which the hardware had already been bought and paid for, and did not fund any significant successor program.
The work left undone was very clear, even before the last missions were flown.
As a trained geologist, Jack Schmitt was the first scientist and the last to walk on the moon.
The Apollo 17 mission took us to a deep mountain valley on the moon, deeper than the Grand Canyon. The mountains on either side were 6,000 and 7,000 feet above us, 2,100 meters or so. What it did, and the reason it was valuable, it gave us a three-dimensional view of many of the things we had only seen in one dimension by landing on relatively flat plains elsewhere. 3 dimensions to a geologist is like ice cream. It is extremely important and delicious to have, and for a geologist, there's a tremendous amount of exploration yet to be done.
3, 2, 1, ignition. Right away, Houston. Vector good.
The mistake of the post-Apollo years, a mistake, frankly, which belongs squarely in the Nixon administration of now nearly 40 years ago, in fact 40 years ago next year, was the decision that the United States would no longer go beyond low Earth orbit.
Even NASA's plans for low Earth orbit were soon scaled back. President Nixon cut the proposed space station, but continued to support the shuttle.
So astronauts for 20 years just flew into space and did some experiments and then flew back. Well, that was never what the shuttle was designed to do. It was designed to be a transportation system to go someplace else. But it eventually became, because of the lack of money, its own destination.
So then, in order to be justified, for the first time, the budget office said it has to be cost effective. You have to show that it's a better way, more economical way than using expendable launch vehicles. And that required more launches, and so you needed more customers. And the only other customer in town was the Department of Defense and the intelligence agencies. So you had to go to the intelligence agencies and say, would you use this vehicle?
You had to be a space truck. It had to carry military satellites. It had to carry scientific satellites. It had to carry people, of course.
It has to be able to take off, fly around the Earth, and land at the same place.
Protected by more than 20,000 thermal tiles, Columbia, the first shuttle orbiter, also needed to survive the fierce heat of re-entry and land safely like an airplane. It could carry a crew of 7 and a payload about the size of a school bus. But combining all the shuttle's functions with cheapness and reusability proved impossible in the end. The shuttle was less like a flatbed truck and more like a Formula One race car, requiring extensive refitting after each flight.
The thing that they learned in the context of flying the first few missions is how hard it was to turn the shuttle around, to process it. It took months on end for all of these orbiters to be prepared to return to flight, and in some cases longer than even a few months.
The defining concept behind the shuttle, the idea that reusability would cut costs, was not turning out that way.
The per-flight costs of the shuttle range from $500 million to over $1 billion every time you fly. You can build a sports stadium with that. So that was one of the great quiet secrets about the shuttle, that the shuttle was going to cost as much to fly as the equivalent rocketry of the 1960s and 1970s. It's very, very expensive. Part of NASA's culture is the belief that if the mission is successful, no one will ever ask what it costs.
During the 1980s, the annual number of missions gradually increased. 4 missions in '83, 5 in '84, and a record 9 missions in 1985. Launch rate was a priority. NASA was subsidizing commercial launches to stay competitive with the European Space Agency. NASA had reduced the fee for a satellite launch to such a low price, the line of customers was out the door.
Launch schedule was a prime consideration. We kept saying that safety is the #1 consideration, but launch schedule was right up there with it. We were showing Congress and the American public that we've got a space truck here and it's ready to go. Let's go start doing other things in space. So we're extremely important that we meet those schedules and keep the operating costs of the vehicle down.
The engineers down in close to the vehicle knew how risky this was, but the upper management chose to ignore the messages of problems and said, we're committed to do this and we're going to do it.
And if you look at all of the responsibilities, the functions that were placed on the shuttle, they all kind of had conflicting design requirements as a result of trying to get too many people agreeing on a single vehicle. The accident, in effect, was planned from the moment of the conception. It might take 30 years to happen, but it was eventually going to happen.
3, 2, 1, and liftoff. Liftoff.
The odds would finally catch up with the shuttle on January 28, 1986.
Throttling up, 3 engines now at 104%. Challenger, go at throttle up.
In a fireball, the shuttle Challenger exploded 73 seconds after launch, killing 7 astronauts, including high school teacher Krista McAuliffe.
Obviously a major malfunction.
Her presence on the mission was widely regarded as a sign that the era of safe and routine space travel had finally arrived.
And I just hope everybody tunes in on day 4 now to watch the teacher teaching from space.
The loss of Krista McAuliffe and the Challenger crew was a severe blow to NASA and to the nation. A distinguished board was assembled to investigate the accident. They found that the shuttle had launched on too cold a day, compromising a thin pressure seal called an O-ring, allowing hot gases to escape and ignite the main fuel tank. The board also learned that several engineers objected to the launch, but had been ignored. NASA, it was revealed, had deep flaws in its culture that were compromising safety.
The Challenger accident was a surprise in 2 ways to us. It was a surprise just to have the accident. The other surprise is that there were engineers that knew the problem that caused the Challenger accident, and they had been trying to bring it forward to the management, and the management wouldn't listen to them.
After the Challenger accident in 1986, the DoD decided that this was just something that they would not be able to support any longer, and they made the decision at that time to pull the military payloads off of the space shuttle and to launch all of them on expendable launch vehicles.
When the program resumed in 1988, the shuttle had lost its military and commercial payloads. NASA's focus then returned to science and discovery. Ulysses, Galileo, Magellan, probes and telescopes examined the far reaches of the solar system and beyond. But the most spectacular mission of them all was the repair in orbit of the Hubble Space Telescope. Story Musgrave performed many of those repairs.
Space has the opportunity to offer you, number one, exploration. It's what kind of universe we got, what's our place in it, you know. People love Hubble images. It tells them where they came from. It tells them where they're going. Brings the world together.
After the Challenger accident, NASA had 6, 10, 15, 20 successful flights. The agency drifted back into the old idea that it was just an airplane. People inside NASA became so convinced that this was routine and operational that in 1996, the agency provided that the shuttle operations would be turned over to a private contractor.
The shuttle workforce had peaked at 30,000 in 1993. But by 2002, it had been cut nearly in half.
Private industry can go in with its cost-cutting models that are used in grocery stores and parts dealership that allow you to squeeze increasingly large numbers of people and money out of a program and run it as close to the margin as you possibly can. But when you push the shuttle to the margin, that's very dangerous.
In 1998, assembly of the long-delayed International Space Station began. The shuttle would finally have somewhere to go. But the space station brought another round of scheduling and budget pressures.
At the time of the Columbia launch, NASA's new administrator, Sean O'Keefe, who was a budget person, had come in to fix what was regarded as the big problem of NASA, which was an inability to manage cost.
Indeed, the reason I became NASA administrator was predominantly because the program management on the International Space Station had become quite confused. These shuttles are a very expensive piece of machinery to fly. The safety regime of this is what makes it so expensive.
In the space shuttle design, where we made a major miscalculation is that we could design it so that the factor of safety would always be that it would fail safe. But there were a number of places on it where it would not fail safe.
Failing safe would mean that a crew could survive a vehicle failure. The capsules of Mercury, Gemini, and Apollo had an auxiliary rocket that could pull the crew to safety if the main rockets failed. But as the Challenger accident cruelly demonstrated, the shuttle had no such failsafe. Even if the rockets didn't fail, the orbiter was still vulnerable during liftoff. During the shuttle's development, there was concern that ice fragments falling from the shuttle's huge external tank could damage the orbiter. The tank contains hydrogen and oxygen, kept liquid at supercool temperatures. To prevent ice, condensed from the moist Florida air, from forming on the exterior, required that foam insulation be applied, a material as light and as brittle as styrofoam. But this presented its own problems. On the very first flight of the shuttle in 1981, engineers noticed hundreds of fragments of foam breaking loose and hitting the underside of the orbiter.
Now, we had all this concern early on about the foam, and we found about 50 gouges in it on the bottom side of the vehicle.
Engineers worried that severe damage to the underside of the orbiter could allow superheated atmospheric gases to leak in during re-entry, which would be catastrophic. But over time, as the shuttle continued to land safely, the foam shedding issue became less and less of a concern.
After STS 1, 2, 3, and 4, it was pretty clear that there was no way of eliminating impacts to the orbiter at the level that were forbidden. So they just basically ignored that. And you know, there were, I would say, on virtually every flight, there were small pieces of foam which would impact on the undersides of the wings, typically causing damage to the thermal tiles.
More than 20 years later, in 2003, as Columbia sat on the launch pad for what would be her final mission, NASA was still studying the problem.
When you see something, however abnormal, often enough, you begin to think it's normal. The fact that it's happened several times and always explainable upon return and inspection, and you look at what the damage was or the effect or whatever and said, okay, that's within a margin of acceptable damage or consequence, and so therefore not safety of flight threatening.
Just 3 months earlier, during the launch of the Shuttle Atlantis, a chunk of foam had gouged a small crater in one of its booster rockets, missing a critical electronics box by inches. NASA ordered an investigation, but it was delayed. The launch of Columbia could not wait. Its science mission had to be completed to make way for the construction of the International Space Station.
The mission wasn't a very sexy mission as missions go. It was a very mixed bag sort of mission. It was a bunch of experiments that had been kind of delayed because they never were fit in somewhere else, and they finally all got thrown together on this flight.
81 seconds after liftoff, a large piece of foam insulation broke off the main tank and hit the orbiter on its left wing. Engineers had seen the impact while reviewing film on the second day of the flight. But mission managers decided the impact did not pose a safety problem. The astronauts successfully completed their scientific work, and the flight was otherwise uneventful. On February 1st, 2003, NASA personnel, families, and reporters gathered near the landing strip at Kennedy Space Center to welcome home the Columbia astronauts.
We were at the landing site, and we wait there on the bleachers with the other families and family members, and there's not nearly as much ceremony with landing as there is for launch.
On that morning, it was a Saturday morning, and we were not going to broadcast the landing live, but I was there on standby like I always am, and I was writing my landing story.
After more than 100 successful landings, the ground control team in Houston was thoroughly familiar with re-entry procedures. But less than a minute after Columbia crossed over the California coast, the first alarm sounded in mission control.
Flight Max.
Go ahead, Max.
FYI, I've just lost 4 separate temperature transducers on the left side of the vehicle.
I mean, you're telling me you lost them all at exactly the same time?
No, not exactly. They were within probably 4 or 5 seconds of each other.
Okay. Where is that instrumentation located?
All 4 of them are located in the aft part of the left wing.
A few minutes later, another faulty reading.
The tire pressure on left outboard and left inboard, both tires.
And Columbia, Houston, we see your tire pressure messages, and we did not copy your last.
Roger.
That was the last message transmitted by Columbia.
At some point, several minutes into it, the thought of the debris that we had seen from the foam and the discussions that we had on orbit came into my mind because it was the left wing. And that gave me kind of a sinking feeling. But again, fortunately, your training kind of kicks in and it forces you to not get zeroed in on any one specific area until you have good reason to do that. But it did sort of cross my mind that this could be a very bad situation if, in fact, we had a breach in that wing, and that's what was causing all this to happen.
Columbia, Houston, UHF comm check.
The clock's ticking down. They've lost comm. Now that wouldn't, if you're going to bail out, you'd still have some communication. So that made me think, wow, something maybe is more serious than just the loss of a landing gear system.
A few minutes into the loss of comm, I knew we were coming close to where we should have been picking up Mila, the ground station. And so I asked the flight dynamics officer, when do you expect tracking? And when he told me we should have had it about a minute ago, that was really bad news.
The weather was beautiful. They had no technical problems. So I went out there expecting it would come by.
And then all the cell phones started going off with the astronauts that escort us, the family escorts. And then, boom, all of a sudden we're rushed to vehicles.
And it never came.
We have a friend of ours who lives in Dallas, Texas, a young kid, a teenager, who was out watching the landing that morning because the track of the orbiter was going to go right over Dallas. And just after I'd sent my friend a note saying, I don't know about you, but I'm getting nervous, he sent me a note from his friend in Dallas, instant messaging once again. And this kid's note was, OMG, oh my God, exclamation, exclamation, the shuttle broke up. The shuttle is broken up.
While Flight Director Leroy Kane was struggling to understand the situation, shuttle enthusiasts watching the sky in Texas could see exactly what was going on.
GC flight. GC flight. Flight GC, lock the doors. Copy. No phone calls, off-site, outside of this room. Our discussions are on these loops, on the recorded Devis loops only. No data, no phone calls, no transmissions anywhere into or out. Okay.
The unthinkable had happened again. But Leroy Kane knew what he had to do.
At that point in time, of course, I knew that we had lost the vehicle. I knew that the vehicle had broken up over Texas. So you go into a mode of making sure we capture all of our notes and all of our data and all of the screens and the configuration. And all of that is very well laid out in a checklist that has to do with these kind of contingencies. When you're training, you hope that you never have to use it. And on that day, we had to use it. And that's the procedure that we were getting into when we asked the ground controllers to lock the doors.
Again, 7 astronauts had perished, prompting another soul-searching investigation.
Ironically, in November of 2002, we actually conducted an exercise where we activated a board. We had listed all the members of the board who would be involved in the investigation. So on the day this happened, at about 9:30, that plan was activated.
The Columbia Accident Investigation Board was headed by retired Navy Admiral Hal Gaiman Scott Hubbard was the dedicated NASA representative. At the time, he was head of NASA's Ames Research Center.
The first month of the board was very much devoted to the recovery of the debris, the operations in Texas, these 20,000 people that were out there searching for what they could recover, both from of the astronauts' remains as well as the shuttle itself.
The debris was spread over a 200-mile segment from West Louisiana all the way to Dallas. And I mean, it covered an area 200 miles long and about 10 miles wide.
And this was a very emotional time. I remember standing there, and that got to you. You know, you really felt a sense of loss. You know, these people had died in this tragedy. Initially, we were very skeptical that the debris could tell us anything. But over time, as we looked at what places were burned, what pieces had a sharp edge because it had been through a very hot environment, I think the debris is telling us something.
Although only about 40% of the actual orbiter was recovered, the condition and location of the pieces that were found led investigators to the wing that had been hit by foam. The accident board also studied footage of the foam impact 81 seconds after liftoff.
A hard hit in a football game, when you see someone bang, oh, you know, you kind of cringe because you have the empathy to know if that had been me, I'd have been hurt.
This was the impact that engineers had noticed while reviewing images of the launch on the second day of the flight.
They knew on the second day of the mission that a piece of foam hit the wing leading edge, that it probably was the size of a small briefcase and probably weighed 2 pounds.
The foam came from the base of a ramp that connected the external tank to the orbiter. It was foam from the same area that had endangered the shuttle Atlantis 3 months earlier. But that was all the engineers knew.
There was also an uncertainty about where the foam had hit. Was it the front of the wing where the carbon panels were? Was it the tile acreage on the bottom? Or was it the landing gear door?
Rodney Rocha was the division chief engineer for the Columbia flight. After seeing the video, he and other engineers had wanted NASA to obtain additional images to check the shuttle for damage.
We have ground-based telescopes, and we meaning the military does, and satellites up there. I'm aware that we used some of that in the early shuttle flights in the 80s. Some of that was used and was classified. So that's why in my email request I said, let's ask, and I actually said, let's beg for outside agency assistance. And I explained why. We're highly uncertain about this problem. There's too many possibilities here. Some of them are very bad.
On the 5th day of the mission, the debris assessment team, including Rocha, made an initial estimate that the fragment of foam was several hundred times larger than average.
This was a big foam strike. It was the biggest one anyone had ever seen. It was a large piece, clearly came off, hit the underside of the wing, and no one knew where it hit.
On the 8th day of the mission, the crew was informed of the incident as part of a routine email. It said, in part, "This item is not even worth mentioning, other than wanting to make sure that you're not surprised by it in a question from a reporter. There is absolutely no concern for entry." But Rodney Rocha was very concerned, and his requests for additional images were denied.
We felt we were in a topsy-turvy world. It's like someone saying, I want you to tell me how bad that car accident is that you just heard out the window. And I want you to tell me if we need an ambulance or not. And you say, Well, I'll go look out the window. And he said, and someone says, no, you may not look out the window. You do your analysis first, and you tell me if you need to call an ambulance first. It's a lot of trouble to call an ambulance. You tell me, you do an analysis first. You tell me an answer first. How can you possibly get out of that kind of uncertainty? It's impossible.
On day 9, the mission managers met to resolve the foam issue. Their meeting was recorded.
Okay, good morning and welcome to the MMT. Okay, go ahead, John.
Okay. We've received, the data from the systems integration guys. The analysis is not complete, but I'm kind of just jumping to the conclusion of all that. But we do not see any kind of, safety of flight issue here yet in anything that we've looked at.
No safety flight, no issue for this mission, nothing that's going to do different.
Right,
there may be a turnaround. That's it? All right, any questions on that?
So this is foam, like the stuff on the external fuel tank, and it doesn't weigh a thing. I mean, this is almost weightless. And I think that even among very smart engineers, there is a very human perceptual quality here that this doesn't weigh anything. So what if it hits you?
But after the accident, the investigation team took a harder look at the foam.
I said, Doug, you want a Nobel Prize in physics? Let's just do some high school arithmetic here, okay?
We knew that the transit time for the foam was, I think, 0.16 seconds.
Here's how fast it's going, okay, and we do some simple high school physics.
The distance is equal to 1/2 AT squared. You can calculate the acceleration, you calculate the velocity.
It would impart a force of roughly 3,000 pounds, roughly a ton of force.
But in fact, NASA management claimed they didn't understand this. I mean, this was very trivial stuff.
And the analogy they always used was as if a styrofoam cooler on a car in front of you in a pickup truck or something blows out on the road and hits your windshield when you're going 70 miles an hour. What happens? And the answer is nothing happens. The styrofoam breaks up in little pieces and falls off. It doesn't break your windshield.
We had a picture of the crew in every single room at the Columbia board, and we would always remind ourselves, we're here in part, at least, because of these people who died and what we owe to them and their families to figure out what happened.
Scott Hubbard, who was a member of the Accident Investigation Board, ran around all over NASA, and at that time he was a center director at the Ames Research Center, ran all over NASA saying, the foam did it, the foam did it, the foam did it, telling anybody who would listen, here's how, this is why, and the foam did it. And yeah, there was resistance to that. People didn't want to believe it, and until they demonstrated it, they didn't really believe it.
NASA has this terrible expression called it's in family. In other words, we've seen this before. It never did anything before. I don't think it'll do anything now.
The investigation board assembled parts from other shuttles to devise a conclusive test. Everyone agreed the leading edge of the wing was probably where the foam had struck. The board went ahead and constructed a life-size model of the wing with plans to test fire fragments of foam at it at different speeds and angles.
I had engineers at NASA, very smart people, saying, they're going to fire a piece of foam at that wing, and it's going to bounce off. Foam can't do that. And these were not dumb people, these were intelligent people. But the physics of it was counterintuitive.
It was a very powerful emotional moment because we'd done all this work for months to get everything ready to do this test. It was very hot. Down there in San Antonio is, 100 degrees every day, and the place is full of snakes and stuff. It's all outdoors. And so I was standing there with all these other officials, and 2 astronauts came up to stand right behind me. And they counted it down to the firing of the gun, and the gun, boom. And we looked, and all of a sudden there was this giant hole in the wing leading edge. And at first I went, yes. And then I went, oh. Because part of me said, okay, we've demonstrated it. But then part of me said, oh, this is how these people actually died. There was one engineer who came from Johnson Space Center, and she actually had tears in her eyes because she, didn't want to believe that the foam did it, but this was so dramatic a test, it showed that there was just no doubt.
After the accident, people said, well, during launch, a problem happened and it was all over for the crew then. It was not all over then. And you don't look to spy satellites or anything like that. It's do a spacewalk. It's just do a walk. And I was not hearing that language from NASA, just do a walk.
Assuming we would have seen the hole in the wing, we would have known it was a carbon panel. We would have known which panel. We would have known the size. And then my colleagues and the contractors would have come up with some kind of response to that. Hundreds, if not thousands of people would have put their brains together and started thinking pretty smartly about how to respond to this, and we would have told the crew, given them some strong suggestions about what to do. And I think they would have done it. Now, would that have worked? I guess I'll never know.
We actually tasked NASA to put together a team of engineers to imagine that it's day 5 of the flight and they've just learned that there's a big hole in the left wing of Columbia. So what could they do about it?
Main engine start. 5.
One group said, well, Atlantis is close enough to being ready to launch.
And liftoff of Space Shuttle Atlantis.
That we basically kind of wind down as far as possible all activities on the shuttle, and without sacrificing any of the normal safety procedures for preparing the Atlantis for launch, that they could get the Atlantis up. It would have to sort of essentially park next to Columbia, and then they would transfer the astronauts one at a time. And then, in fact, you could bring those guys back.
The board found that although the odds of success were low, the rescue scenario might have worked. But the Columbia crew was unaware of the danger until the very end, as confirmed by one last piece of evidence.
During the search for wreckage, I interviewed a guy who one day was, they had gone out, because people were calling in, there's debris here, there's debris there. And these guys, they'd send somebody out to check out everything. And these two guys went to this house, and it turns out whatever it was nothing or something. And they walked back to their truck, and they're on the side of a country road in Texas. And they're standing by the back of this pickup truck, and one of the guys looked down on the side of the road between the asphalt where there's a little gravel and then grass. He sees this cassette. And it looked like an audio cassette, like it's Texas. It'd be country western music or something, but it was a little thicker than an audio tape. And he picked it up. And he said, that's interesting. It didn't look like a audio tape. And they put it in a bag just for the heck of it, and they turned it in. And that was the tape from the flight crew's own video camera that Laurel Clark was using during reentry to film the crew.
We'll go. That's 304.
Yep, looking good.
And that is the only video you have of the crew on reentry day. And I remember the day that video was released and NASA put it up on the satellite and we all watched it. That's what got me. Because you're watching the crew on the flight deck, and you knew what had happened to them, to the second. And you knew that when this tape ended, because it was burnt, from falling back to Earth, the end's not on there. When the tape stops, they're all alive and healthy, and they're a few minutes away from death, from violent death.
I know that's a light cable. Sorry, I didn't understand it.
Dashback, Casey, if you got any.
Yeah, gray taping, you can just give it to us. I'm trying to see if I can get an overhead window view yet.
This is amazing. It's really getting fairly bright out there. Yep. Yeah, you definitely don't want to be outside now.
Like we did before.
As the orbiter descended back towards Earth, the heat produced by re-entry brought the shell of the vehicle up to the standard 1600 degrees Celsius. Shuttle watchers in California witnessed the fall of the first fragments of debris. Superheated gas had already penetrated the left wing through the hole made by the foam impact. It slowly began to destroy the vessel from the inside out. The shuttle's autopilot fired thrusters to compensate for the drag on the damaged wing, but it was too much. Columbia broke apart over Texas, 16 minutes before it was expected to land in Florida.
At the beginning of the Columbia board, we didn't know much about the cause. We didn't know much about what the shuttle program was supposed to be doing. Later on, we came to understand that there was an unspoken contract between the crew and the people on the ground, that the crew will do all they can to make the mission successful, and the people on the ground, the engineers and the managers, will do everything they can to keep the crew safe and to bring them home safely. And I think we developed a sense that maybe the astronauts felt like the people on the ground hadn't done everything they could have done, and some things fell through the cracks.
When members of the Columbia Accident Investigation Board released their findings in 2003, they were unflinching in their critique of what they called NASA's broken safety culture. They concluded the management team operated outside of the rules, even as it held its engineers to a stifling protocol. But the board members didn't limit their judgment to dysfunctional management.
I remember making the comment, and I wasn't alone, that if you're going to risk people's lives, that ought to be for a purpose. And out of these discussions grew what's in the last part of the report, which is to say, look, NASA needs to figure out why it's doing this. And the space science program is well established with the scientific community, but why are we doing the human spaceflight piece? And it's my belief, and I believe this is accurate, that that report led directly to the vision for space exploration.
The vision for space exploration was announced by President Bush in January 2004. It directed NASA to build new spacecraft that could take astronauts beyond the confines of low Earth orbit. And it mandated the retirement of the shuttle.
The decision has been made, and I think it's a correct one, to go back to a heavy lift launch foundation because it offers us so many other things we can do. The shuttle can't go to the moon, and it can't go to Mars. And it really does not give us the capability to build craft and put craft into space that can do those two things.
To speed the transition, the new suite of space vehicles called Constellation will be based largely on proven technology.
Constellation actually, in its architecture, utilizes a number of pieces of both Apollo technology from several decades ago and shuttle technology.
Solid rocket booster and fuel tank design from the shuttle. Engine and rocket design based on the Apollo moon rockets. But unlike Apollo or the shuttle, the new system launches crew and cargo separately.
Every time the shuttle lifts off with a cargo and a crew, it carries 120 tons of payload to orbit, of which 20 tons is cargo, and all of the rest is support elements for the crew and the cargo itself. So in that sense, unless your objective is to put people in orbit, most of the shuttle capability is wasted. On the other hand, if your objective is to put people in orbit, then what are you doing with this 15-foot diameter, 60-foot long payload bay in the back?
In addition to their new capabilities, the spacecraft eliminate the major safety flaws the Columbia board identified with the shuttle.
You can get an immediate factor of 10 improvement in safety just by moving the vehicle from the side to the top, like in Apollo.
A capsule on top of the rocket cannot be hit by the kind of debris that doomed Columbia. It also allows for a crew evacuation system that could have saved the Challenger astronauts.
we are returning to a design which has a crew escape system. There will be an escape tower, an escape rocket on top of the Orion crew vehicle that in the event of an emergency will allow the crew a second chance.
T-minus 5, 4, 3, 2, 1.
Before being retired, the shuttle will continue to be used to finish construction of the International Space Station. Cameras on the space station, as well as on the shuttle's robotic arm, are being used to detect damage to the orbiter. New techniques have been developed to limit the amount of foam shedding and even repair damaged tiles in space. After more than 2 years in dry dock, the shuttle resumed flight on July 26, 2005, with mission STS-114. Aboard the Discovery, once in orbit, Commander Eileen Collins spoke.
As our crew looks back at our beautiful planet and then outward towards the unknown of space, we feel the importance, today more than any time, of space exploration to all those who are living on Earth. Our flight is the next flight of many in the human exploration of the universe. And finally, we reflect on the last shuttle mission. The great ship Columbia and her inspiring crew, Rick, Willie, Mike, Casey, Dave, Laurel, and Elon. We miss them, and we are continuing their mission. God bless them tonight, and God bless their families. Good night.
Thank you, Eileen, and the STS-114 crew. We miss them, too.
Could the astronauts have been saved? On NOVA's Space Shuttle Disaster website, examine how a high-risk scenario to rescue the crew might have unfolded. Find it on pbs.org. Major funding for NOVA is provided by the David H. Koch Fund for Science, supporting NOVA and promoting public understanding of science. And by the Corporation for Public Broadcasting. And by contributions to your PBS station from viewers like you. Thank you. Additional funding from Lockheed Martin, inspiring tomorrow's engineers and technologists. To order this NOVA program for $24.95 plus shipping and handling, call WGBH Boston Video at 1-800-255-9424.